Hello everyone. So our next question is combination sum. Okay, let's go to the question. Given an array of distinct integer candidates, okay, and target integer target, return a list of all unique combination of candidates where the chosen numbers sum to target. Okay, like there are some numbers given and there some will become target. You may return the combination in any order. Okay, the same number may be chosen for candidates an unlimited number of times. Okay, two combinations are unique if the frequency of at least one of the chosen numbers is different. Okay, so it depends on frequency. It is guaranteed that the number of the unique combinations that sum up to target is less than 150 combinations for the given input. Okay, so we are given like we have 2, 3, 6 and 7. Okay, now we have our target is equal to 7. So what we have to do, we have to choose some integers and we can pick one integer more than once, so like 2 plus 2 plus 2, okay, not 2 plus 2, 2 plus 2 plus 3 is equal to 7. We can pick this. The another one is 7 and okay, there's no other answer. Yeah, here also only two outputs are there. So it looks like a recursive function to me, but let's see. So we have to take all the possible combinations. What we could do is, let us say we have our 2, 3, 6 and 7. Okay, so if, and here was one more thing is there, like the possible combinations are not more than 150. Yeah, here target is less than 150, so it can help us, like we have to go for 150 cross 30 something, this the complexity like this. Okay, so what we can do, either we can use a recursive function. Yeah, recursive function will be required. We have 2, 3, 6, 7 and their count. Okay, so we will create a dictionary. We will put all the numbers and their count inside it. Okay, as number will be our key and count will be our value, key value pair. Okay, then after creating that dict, we are gonna search for target first. Okay, if we got the target, okay, we have our answer. Else uh, we will check for next minimum number. So our next, if our next minimum is like 6 and our target is 13, so we can take 6 multiple times, 6 plus 6 plus, okay, then we will check for 1 is there or not. Okay, these all look like recursive function to me. Like if we have 2, 3, 6 and 7, take 2, now search target minus 2 in this part and in this part. Okay, and if at any time, okay, yeah, and if at any time target is less than 0, then break it. If target is equal to 0, then okay, we have our answer. Yeah, this should work fine. Well, let's do it. So we are gonna say, let's take a helper function. It will be our recursive helper. Okay, so what we are gonna pass? We are going to pass the ith index we are checking for. So yeah, ith index. Now, and we also need our target. Okay, so call helper on I comma target minus candidates I, all the candidates of I. The same we are gonna do for I plus 1. Control V for I plus 1. Plus is not working here. And okay, no. We are gonna use our I and we'll call for I plus 1. Or no, directly call for I plus 1 and use candidates of I plus 1. Right, rather just directly call on I plus 1. Okay, yeah, instead of using I. So yeah, and if now we need our base case, this was our recursive calls. This was our recursive call. What we did, we find whether we have two choices now here. Our first choice is whether this will be included to and whether this will be deducted from target, or else we will go to the next index. Okay, so here it is deducted from target and we are still on the same index, or we go to the next index. Okay, yeah, it will work fine. So if I is equal to 0, yeah, that's why when we are going to memorize it, it will be 150 cross 30. So if I is greater than yeah, if I is greater than equal to, let's see, greater than equal to length of candidates, then return. Okay, return. And we also need all the indices which are taken. Okay, so for that we need to maintain an array. Let us suppose array of indices. Okay, that could be okay. So this is our result indices. Initially it is empty, and whenever we are subtracting any candidates, we are gonna add it. Result of indices plus the ith index. Okay, cool. Now what we will do here, if I is greater than equal to length of candidates, then return what? Return 0, return, then return, yeah. Okay, before that we need one more base, like we need one more check. If target is equal to 0, okay, then here we have our result, then result dot append all the values in that indices. Okay, we can take a set rather, such that we don't have any duplicates. And to not have any duplicate, what we can do is we can sort it. Would we have some duplicates or not? I don't think so that we are gonna have some duplicates if we already pass out the sorted array. So let's sort the candidate array. Sometimes you have to be greedy, even you don't know the proof. I mean, it's intuitive that it might happen. So I'm also going like candidate sort. Then result is the set. I'm gonna append result of indices. Okay, and tuple of candidates of I, or not I, candidates of IDX or IDX in result indices. Yeah, this will work. And okay, it's already 9 minutes. This will append our result and it just return just after this. Okay, after doing this, or if I is greater than equal to length of candidate, okay, not greater equal to, if I is, yeah, greater than equal to, but before it we have to check one more thing, so that if target is less than 0, we don't have any negative number inside it now. Yeah, if target is less than 0, then just return, we don't need you. Yeah, so if I will be length of candidate, either this will return the real answer or it will go to the next. Yeah, it might work, it should work, I guess. So these are the base cases I have taken. Yeah, 3, like if less than 0 is equal to 0, or it will cross length of candidates. Okay, so we can put or in here. Or or if I is greater than equal to length of candidate, then return directly. Now what we have to do is, okay, these are sets now. So return, we have to return list of it. Before that, let's call our helper function. So what will be I? I will be 0 initially. Target is target itself. And okay, yeah, cool. And return list of integer. Okay. So return list of res. Okay, it should work. Let's see. Invalid syntax. So I have appended for idx in res a tuple of, oh sorry, tuple. This should be used to convert a list into tuple, because a set can't, okay, a set can't take a list as an input. It should take tuple. List will be hashable type, so it can't take 7 and 3. 7 and 3, it is returning 7 and 3. Where is 2, 3, 3? If target is, so target is 0 at 3. Okay, how could that be possible? So it is leaving 2 and 2s. To cope up with this position, what we can do is, we are calling it on I plus 1, 2. Okay. Let's print our I comma target. Print I comma target and comma res indices 2. It will be a big call, but whatever. 0, 7, initially it is 0, then 2 is taken. Yeah, okay, not 2. Yeah, 2 is taken. 0, okay, it is not appending the real index. Why? I is there. It is appending 0, 0, 0. Okay. So there are 4 zeros and it is negative. Else, there must be somewhere 0, 0, 1. No, it is not anywhere. So the problem is, after taking two twos, it is not taking any 3. Oh man, this is weird. Let's see. If target is less than 0, or this, there. But here it should go to helper I plus 1, and it should have taken target minus candidates of I means target minus 3. and res indices is res indices plus I. Into comma target res is here. Result, I'm adding tuple of it. I don't know why it is like looking like this. It should work. We have our logic correct. Like if I is there, go for I plus 1. If you are at the end, get. But after 000, why it is going for 000? It can go for 00 also. Length of candidates, I'm every time passing candidates. Target is there. If target is equal to 0, then res dot add tuple of this. Let's print our res too. Sorry. Okay, set is always empty. So for 111, okay, the problem is within set. Instead of taking set, let's take a simple array and append it. Because somehow it will be always unique because I have already sorted the array, or it won't be. Yeah, it might not be unique always. We need to take set, and what I can think of is result indices is not getting updated because I'm always passing the same reference. I have to pass its copy. Okay, you have to copy it and then pass it for the next value. That could be one of the case. The result indices dot copy plus I, and in the end we are getting 7 and 3. No. Okay, so the problem here is this res indices is passing as a reference because it is an int array. So to pass, we have to pass it by value, and every time we have to append it inside our result. So to do this, what we can do is we are gonna pass string arrays. Okay, so initially it is nothing, then every time we are adding str of I. Okay, and here it will be int of idx. Now this will work. Okay, I mean this should work. Not will is passing, everything is going on. Let's see the output. Again it is okay, the 001. See here 1 3 is there. Okay. Oh, I have forgotten to pass the res. Shit, man. It should be passed here. Okay, now it will be good. So after passing res indices inside it, now okay, let's see. Yeah, it is accepted. Oh, such silly mistakes, man. We have to we also have to pass res indices here. If we won't pass it, it will take it as empty. So it could be it could have benefits, but here you see that it went wrong. Okay. It was a 10-minute question. Like, okay, let's see. Okay, submitted. Thank you guys. And we can also memorize it. It is saying this much milliseconds, so let's memorize it, and after that we will leave. Can you memorize it? Okay. Yeah, we can. So if we have already checked an ith index, no. Yeah, if we have already checked I comma target, we don't have to check it again. Let's see whether it will make some sense. From memory usage is less than 13.808. I guess it's because I'm copying everything. That's why it is taking this much memory. Let's see the solution. Backtracking. Let's go for Python 3. Okay. So okay, it is yeah, we can do it with DFS also. Search all the possible. Okay, okay. Yeah. Candidates was sought. Dot DFS from target from 0. Oh, I'm doing same. For I next range, either do target of okay. No, it is every okay, yeah. It is not also taking. I don't know. Okay, whatever. Thank you guys. Subscribe for more questions. Meet you soon.